Okay, so we just did the easiest problem there is for us to use, which is looking at half of a parabola. Now I want you to look at a whole parabola, a two-dimensional kinematics problem. Soccer ball is kicked off the grass and travels 50 meters in 8 seconds. What's the velocity of the soccer ball when it's kicked, including both the size and direction? What is the maximum height of the kick? Of course, if you're a sports fan of any type and you've ever seen a ball kicked, thrown, you probably have noticed the parabolic nature. We're going to start nice and easy where the ball is kicked off the same level that it lands. So here's my picture. Alright, so here's my soccer ball. It's kicked, goes through the air, it's decelerating due to gravity on the way up, it's accelerating due to gravity on the way down. Again, these are mirror images of each other because the time it has to decelerate on the way up is the same amount of time it has to come back down. Again, we're ignoring air resistance, so when we're setting this problem up, we're going to have an up column of information for kinematics and a down column of information. Alright, we're also going to have the horizontal information, which I could call x, where we have the velocity in the x, the displacement in the x, and the time in the x. Notice there's only 3 variables here because we're saying it moves at a constant velocity because we ignore air resistance. Over here, you might want to note that we've split the time in half. Because this is a perfect parabola, we can do that. If for some reason somebody caught the ball up here, headed the ball, trapped the ball, we could no longer split the time in half. Similar to throwing the ball up and letting it fall back down, at the top of the parabola, it's stopped rising and it's about to start falling. Momentarily, the final velocity is 0. The acceleration is negative 9.8 all the way up. So we're going to do two things. We're going to find the x component of the velocity and the y component of the velocity. Of course, because these are vectors, when we actually give our final answer, we'll use the Pythagorean theorem to get initial velocity, and we'll do tan inverse to show the direction that the ball is kicked at. Okay, so sorry for my smartboard notes kind of being on top of each other. I'll ruin the surprise. First I did Vx equals x over t. I know the ball travels 50 meters in 8 seconds. I simply divide and I get 6.25 meters per second, which is the x component of the initial velocity. For the y direction, I'm going to use a kinematics equation. Choose the equation without d because we don't know how high up the ball rises. V equals v naught plus at. We substitute in our numbers. We do some algebra. We get 39.2 meters per second. So I label my final triangle. I do Pythagorean theorem. A squared plus b squared equals c squared. I get that the ball is actually traveling at a total of 39.7 meters per second. And if I do tan inverse equals the opposite leg over the adjacent leg, I get that this soccer ball was kicked at an angle of 80.9 degrees. Certainly not the most effective soccer playing, but the physics looks pretty good. Okay, to find the max height the ball travels, we can just go back and choose one of our kinematics equations. I chose d equals vt minus 1/2 at squared, because since v final is 0, that term will go to 0. Plug and chug, the ball rises 78.4 meters. Notice we never had to look at the down column of information because it's pretty much the mirror image of the up column. Alright, let's try a harder problem. In a scene in an action movie, a stuntman jumps from the top of one building to the top of another building 4 meters away. After a running start, he leaps at an angle of 15 degrees with respect to the flat of the roof while traveling at a speed of 5 meters per second. Will he make it to the other roof, which is 2.5 meters shorter than the building he jumps from? So here's my picture. It's always good to start with a picture. And here's my kinematics setup. I have my x displacement, no acceleration because we ignore air resistance. We have our up column and our down column. This time these will not be mirror images because he falls down farther than he went up. Okay, so what do we know? Well, one of the most important pieces of information is the fact that he jumps at an angle of 15 degrees. So of that 5 meters per second he's running, a piece of it is in the x direction and a piece of it's in the y direction. At the top of his jump, he stops rising because he's decelerating at negative 9.8. I don't know how high up he goes up, and I don't know how long it takes him to get there. On the way back down, he starts from rest. He's accelerating at 9.8, and however high up he rose, he will fall that distance plus an additional 2.5 meters. All right, so now what do we do? Mostly I need a plan. My plan is to solve for this x by finding the time to go up and the time to come back down. If he travels less than 4 meters over, he'll fall. And if he travels farther than 4 meters, I'm going to say he makes it, specifically because we don't know the length of this other rooftop that he's jumping onto. So the first thing I'm going to do is find the distance that he travels up and the time he travels up. I'm going to choose two different kinematics equations. I'm going to go ahead and take 5 sine 15 and get this 1.29. Substitute into v squared equals v naught squared plus 2ad. Plug, chug, algebra. So he's jumped up about 0.085 meters, which is 8.5 centimeters. The time it takes him to reach that is 0.13 seconds. Again, choose an equation, plug, chug. Now, how does this change the information I have? Well, let's look. Now, I know everything there is to know in the up column. I also now know that he's going to fall down 2.585 meters. Now, it doesn't ask how fast he's traveling when he hits the rooftop, although we could certainly calculate that. We don't need to. It asks for, does he make it? So I'm going to solve for the time to go down using d equals v naught t plus 1/2 at squared. Substitute in my values and do some algebra. I get 0.73 seconds. Okay, so the total time of flight is 0.13 seconds up and 0.73 seconds down for a total of 0.86 seconds. Well, I know that his Vx is going to be 5 cosine 15, which turns out to be 4.83 meters per second. I substitute into the equation, I solve, he jumps 4.15 meters, which means he makes the jump by 15 centimeters. All right, so those are 3 types of parabolas looking at two-dimensional kinematics. The previous video showed a half parabola. This video showed a full parabola and an uneven parabola, all of which are common types of physics problems. Good luck.